Hi everyone. So in this recording we will see one second prize sealed bid auction game. So this question was asked in the midterm examination in the Department of Economics at Delhi University. So we are given with these two bidders, and the first condition is the valuation V1 is greater than V2 and it is greater than 0, and it is known to both the players. The highest bidder gets the object, and here it should be pays the bid of the other bidder. That's how the second prize sealed bid auction works, right? And in case of tie, the winner is chosen randomly, and we have to find all the pure strategy Nash equilibria of this game. It is quite challenging game because we have to think in our head all the possible cases. So firstly I will show you the cases, total cases, and I will show you graphically also how you can visualize all the possibilities. Okay, so we have one condition. So V1 is greater than V2. Now when the players are bidding, the case can be B1 is greater than B2, which means player 1 winning, right? And in this case, the utility for player 1 will be V1, the valuation of the player 1, minus B2, because he or she will be paying the bid of the second highest amount. And if it is like this, then it will become player 2 will win the auction, and the utility will become what? V2 minus V1. I hope there is no confusion regarding this, because this is how the second prize sealed bid auction works. Right. Now, I will be making cases. So, if you observe carefully, there will be total 4 boxes which I need to fill. 1, 2, 3, 4. So, you will get to know in a while. So the first condition and the only condition is this: always I will find V1 is greater than V2. So in how many ways I can fill all these 4 boxes? So its answer is 4 factorial, right? So this will come out how many? 24. Now since the position of V1 and V2 are fixed, which means if V1 is here, then V2 can be somewhere here. If V1 is here, then somewhere here. If V1 is here, then it will be somewhere here, right? And B1 and B2 can be adjusted accordingly. So I have to divide it by 2 factorial. Okay, so it will come out how? How many? 12 ways. So there are 12 cases. So I will be taking first this case. So what I will do, I will be making cases where somewhere V1 will be greater than, likewise somewhere it will be V1 greater than B1 is greater than V2 greater than B2, likewise. So you will see in a while all the cases, and you will be able to find all the pure Nash equilibrium of this auction game. Okay, so let me consider the bigger case 1, where player 1 is winning. Just to make you understand, I am writing player 1 winning so that it is easier for me to make the cases, right? So the first case is V1 is greater than B1 is greater than V2 is greater than B2. Because player 1 is winning, it will always be B1 greater than B2, right? Then only player 1 will win the game. And it is already given V1 is greater than V2. So now if you observe carefully expected utility for player 1 is equal to V1 minus B2, and expected utility for player 2 will be 0, right? Because he is winning nothing. So, is there any profitable, sorry, is there any profitable deviation for the player 2? The answer is no. If he bids anything higher than V2 or B1, sorry, in order to win the game, he has to bid higher than B1. So, in that case, the expected utility will become negative, and 0 is obviously better than negative payoff. So, yes, it is a Nash equilibrium. This case is a Nash equilibrium. Okay, now let me take another case. So, what can be the next case? It can be V1 is greater than B1 is greater than B2 is greater than V2. So, what will happen here? Again, the expected utility will be V1 minus B2, and expected utility for player 2 will be 0. If he bids higher than B1 player 2, then again the expected utility will become negative. So, yes, it is a Nash equilibrium again. Okay, now let me take another case. So, there will be total 12 cases. 6 case where player 1 will be winning, 6 case where player 2 will be winning. Okay, now the third case will be this: P1 is greater than B2. Player 1 has won the game, V1 is greater than V2. Now, what will happen? Here, expected utility for player 1 will be V1 minus B2. Because B2 is greater than V1, this will become 0. And expected utility of player 2 will be what? So, since he is not winning the game, so right now it will be 0, but it is in the profitable. I mean, player 1 can reduce its utility from negative to 0 by simply underbidding the player 2. Hence, there is a profitable deviation. Hence, not a Nash equilibrium. Nash equilibrium is what? There should be no profitable deviation for any player from that strategy, right? Okay. Now, consider case number 4. V1 is greater than V2 because we have to follow this, and B1 is greater than B2. Now, take a pause and now try to answer it. So, expected utility for player 1 will be what? V1 minus B2, right? Which is greater than 0. Expected utility for player 2 will be 0. Right? Because he is not winning. But is there any way by which player 2 can increase his bid? Yes. If he bids higher than B1 but less than V2, then he can get strictly positive payoff, which means there is a profitable deviation. Hence, this is not Nash equilibrium. Okay. Now, consider another case. So, case number 5. 5 can be what? B1 is greater than V1 is greater than B2 is greater than V2. Okay. So, again, player 1 is winning. So, expected utility for player 1 will be V1 minus B2, and it will be greater than 0, right? Expected utility for player 2 will be 0. Is there any way by which player 2 can increase his bid, increase his payoff? The answer is no. If he tries to bid higher than B1, then he will be in loss. Hence, yes, it is a Nash equilibrium. Okay, now the last case where player 1 is winning will be B1 is greater than V1 is greater than V2 is greater than B2. Yes, they all are unique. I hope. So expected utility for player 1 will be what? This will be V1 minus B2. And again the player 2 cannot bid higher than B1. Hence it is a Nash equilibrium because there is no profitable deviation. So there are how many? 1, 2, 3, 4. There are total 4 Nash equilibrium where player 1 is winning the game. Now, let's consider another case. A bigger case. Player 2 is winning. Okay. Now, what will happen? This time, it will be B2 is greater than B1 always. Right? Because player 2 will win if and only if he or she is bidding higher than player 1. So this will fall automatically. So the case 1 will be V1 greater than B2 is greater than V2 is greater than B1. Now, what player 1 can do is he can simply bid less than V1 but more than V2. Sorry. I'm getting confused between V and B pronunciation. So I'm saying if he bids, let's say, if he bids like this, V1 greater than B1. So as you can see, he has increased his bid from B1 to slightly lesser than V1 but greater than B2. He is winning the game and there exists a profitable deviation. Hence, not a Nash equilibrium. This case gone. Okay. All right. Consider another case. So this is quite challenging question. I know, but I hope you are getting it what I am doing right now. V1 is greater than B2 is greater than B1 is greater than V2. Right? So, what will be the expected utility? Expected utility of player 1 will be 0 because he is not winning anything. And expected utility for player 2 will be what? V2 minus B1. His valuation minus the second highest bid. But is there any way by which? Wait. His valuation is lesser than B1. So this is negative. Right? So he can make it up to 0 by bidding less than B1 or less than V2. So this is also not a Nash equilibrium. Not Nash equilibrium. Right? Okay. Let's move to another case. Okay. So B2 is greater than B1. Player 2 is winning. V1 is greater than V2 because this is the condition given in the question itself. So here again, if you observe carefully, this time again expected utility for player 2 will be what? V2 minus B1, again negative utility will come. So he can make it to 0 by simply bidding less than B1, right? So again, it will not be a Nash equilibrium with the same logic as in case number 2, not a Nash equilibrium. Now take another case. Here V1 is greater than V2 is greater than B2 is greater than B1. Now what will happen? So expected utility for player 1 will be 0. Expected utility for player 2 will be V2 minus V1, and this is now greater than 0. But what player 1 can do? Player 1 can simply bid higher than V2 and less than V1 and increase its payoff from 0 to some positive number. Hence, this is also not an Nash equilibrium because there exists a profitable deviation, right? He is simply bidding higher than V2 but less than V1. Okay. Now consider another case. So case number 5 can be V2 greater than V1 greater than B1 greater than V2, right? So here expected utility for player 1 will be 0. Expected utility for player 2 will be V2 minus B1. So if you observe carefully, V2 is less than B1. So this means it is negative. And how he can make it up to 0? Player 2 can just bid less than this B1 and can make it to 0. Hence, it is also not a Nash equilibrium. Okay. Now the last case, B2 greater than V1 greater than V2 greater than B1. Okay. Now the expected utility for player 1 will be 0 because he is losing the game. Expected utility for player 2 will be what? V2 minus B1. Now here it is positive and there is no mean by which player 1 can increase its payoff. If he bids higher than V1 any amount, then he will get negative payoff. That makes no sense. Hence, yes, it is a Nash equilibrium. So there are total how many? There are total 5 Nash equilibrium of this game. Yes, let me highlight it. Let me change the color also. Yeah. So one is this. One Nash equilibrium where player 2 is winning. 2, 3, 4, 5. That's your answer. So these many conditions you have to write. These all are the way of Nash equilibrium. Okay. So now I've seen the recording is already long enough. So you can write all these 5 conditions and that's your answer. And for the graphical thing which I mentioned in the beginning of the recording, I will give you a link in the description box. The professor name is Salsuk Oziart. He's a phenomenal teacher for game theory at least, and I have not seen his other videos, but I'm sure those subjects are also covered by him very well. So you can watch Salsuk Oziart's video. Thank you so much.
If you learned something valuable from this video, please press the like button to make YouTube happy. If you'd like to support my work and help me keep creating more content, you can scan the QR code on the screen. A lot of time and effort goes into recording and editing. Thanks for watching, and I'll see you in the next one. Till then, stay safe, stay happy.